Now let's go on to number 18. Here we have some overlapping right triangles. So for overlapping triangles, you always are going to want to draw them separately. So we have the small triangle and the big one, ABC and ADE. They're both right triangles. And let's label some side lengths. AB is root 34. AC is 3. CE is 21. So if you have CE as 21, that's 21 right here and 3 right here. So AE will be 24. And if we need the area of ADE, the bigger triangle, what we really need is this X right here. So not entirely easy to do because the sides that we're talking about don't correspond. But that's an easy fix. We can use the Pythagorean theorem to find BC. So let's call this y here. And for that triangle, we can say a squared plus b squared equals c squared. 3 squared plus y squared is root 34 squared. 9 plus y squared is 34 because the square root of 34 squared, those two things cancel. Take away 9 from both sides and we'll have y squared is 25, square root of both sides, and y is 5. Really plus or minus 5, but in geometry, you're not really going to ever have a negative side length. So we just figured out that this value right here is 5. Now we can write a proportion. We can say this over this equals this over this. And that can be our proportion. So let's write that out. 3 over 24 equals 5 over x. Cross multiply. 3x is 24 times 5, which is 120. Divide by 3, x is 40. And now we have enough information to get the area of triangle ADE, the bigger triangle. We can use, for a triangle, the area is 1/2 times base times height. And that's going to be 1/2 times 24 times the height of 40. And just doing a little mental math here, 1/2 times 40 is 20. And 20 times 24 is 480. And that is the area of the big triangle. So that's our answer.